We have a square root problem. And the way Wells wants you to do this is the way you've done polynomial problems, which is basically go through this algorithm over here. I find it painful to do it, though, to be honest with you. But I will say this, though. It's a square root, so you're going to be following the algorithm that's outlined over here. So if I were looking at that, certainly I know it starts with a number, and the number it's going to start with, it's going to start with 300. And the reason for that 300 when squared would match this number over here. All right. Then you say after 300, what comes next? A tens place, and then a ones place, and then a tens place. Now you may wonder why. I know it's ending at a tens place. I'm seeing this over here as 64 100ths, and that's really going to be 8 tenths when squared. So it's going to end in the tens place. So you go through the algorithm over here, and this is still being taught today, by the way. Now, it's taught in a rather repetitive way, and I always find it very difficult to follow. But it's based on this over here. It is based on this. So I kind of know the beginning of it, and I kind of know the end of it. So what I mean by that, begins with 300, it ends with 8 tenths. What I don't know is what's in the middle of it. So that's the tens place and the ones place. But I still go through the same algorithm. Now, granted, back in Wells's time, people's ability to actually take a square root was considered important. All right? So arithmetic played a much higher position. Now arithmetic's been relegated to the calculator. So I want to go through the calculator, but I will talk about, again, I know the beginning of the number, it's 300, and I know the end of the number, which is 0.8. Again, why do I know it's 300? I'm seeing the 90,000 there, which means 300, it squared is 90,000. And why do I know it ends in the 0.8? I'm looking at it, and I'm assuming it's perfect square, it's 0.8 when squared is 0.64. All right? So let me go to Sage. Let me pull it over so it's lined up with this over here. And I'm going to type it in. Square root SQRT. Whoops, I can't do that. And then it's going to be 99. Oh, you know what? Maybe I should do the 300 squared for you first. Make sure you understand what I'm saying about this over here. 90,000. And remember I said about 0.8 squared. Oops. Was 0.64. All right, not bad. Let me clear the screen. Let me go back to the square root now. SQRT. And what I don't know in between the number, like for example, I know if I do, let me put this over here, 300.8 squared. I know it's going to give me the first digit, that's the 9, and then that decimal place, which is 0.64. All right, it's the middle part that's tough. It's what's going there. All right, let me clear the screen again. And this is the whole algorithm here, finding the middle part. Remember, they find the leader, and then they trail themselves off until they find the end. I always had the beginning and the easy to find now. It's the middle that's tough to find. It's always the middle. Let's write this down now. And Sage is going to return the middle to me immediately. You might have a suspicion about it at this point. Let's see, 99729.64. And you get 315.8. Again, I knew about the first. I knew it was going to be 300. I knew it was going to be 0.8. What I didn't know was the tens place and the ones place. And that's the whole point of the algorithm, to find out what's in the middle. It's tough, though. All right, I don't find it an easy thing to do. I want to point out his algorithm does work nice. I really shouldn't call it his algorithm. I probably predates, taking square roots has been something that's been done for a very long time. Now, I realize in some countries they still teach this. They still teach the algorithm, but it's based on polynomial. But when the algorithm's being taught, they don't even mention the word polynomial, but it's based on polynomial. Thank you.